Hello everyone. This session I'll be discussing polynomials with you. And in this introductory session, I'll explain better the origin of polynomial, some practical application, and the most useful topic in polynomial which you need for entrance examination, just an introduction to it. That is what factor theorem, remainder theorem, and then zeros of polynomial. See, polynomial is the language of algebra. If I say polynomial is the language of mathematics, I won't be wrong some extent. Such a useful topic which you need in your daily life, in sciences, and in maths itself. For ISI CMI entrance examination, polynomial plays a very important role. In every year, I have seen questions in CMI descriptive paper, questions asking from polynomial. And for ISI exams, polynomial is an integral part. Otherwise, question will be there in descriptive part, or you may find it. If you don't find it there, it is in MCQ part. So studying polynomial is a very important topic for you. What is polynomial? Polynomial. It is actually made of two terms, poly plus nomial. It is derived from the Greek word poly, which means many, and nomial meaning term. Many terms will constitute a polynomial. The concept of polynomial has been used for centuries, with the term first being used by Francois Vitet in the 16th century. He was a French mathematician, and in polynomial, studying Vitet's theorem is essential. Obviously, we are going to do it in future. Now, what are the practical applications of polynomial? Let us know it, because a topic in mathematics you are doing for ISI, CMI, whatever, any entrance examination, Olympiad, JEE, all these things, you must know the application of a polynomial. In economics and business, I'll start with this. These are used in economics to model cost function, revenue function, and profit function. They help in understanding the relationship between different economic variables and in making predictions. In physics, polynomials are used to describe the motion of object. Projectile motion is the best example. Those who are in class 11, 12, they knew it. The position of an object moving under constant acceleration can be modeled using a polynomial equation. The example I was telling you, that is on the very first example, will be equations for motion, projectile motion, all these things. Computer graphics. These are used in computer graphics to create curves and surfaces. Bezier curve, which are used in vector graphics and animation. This is very practical side of learning computer, are defined using polynomial equations. Signal processing. Polynomials are used in signal processing to design filters that remove unwanted noise from signals. I am unable to tell you today what way it does, what way polynomial works over there, but if you have interest on this topic, I'll tell you better, study on it in details. They help in analyzing and manipulating signals in various applications such as audio and image processing. Medicine polynomials are used to model the growth of tumors and spread of diseases. Now, medicine sciences is not different from the subject you are going to study. Mathematics is an integral part there. Spread of disease, growth of tumors, this is being studied with the help of polynomial. Many applications are there in medicine, but this is one of the applications of polynomial. They help in understanding the progression of diseases and developing treatment strategies. Now, this topic you will like most, roller coaster. This is the design of a roller coaster. Polynomials are used in designing roller coasters to create smooth and safe curves. Engineers use polynomial equations to model the paths of the tracks, ensuring that the ride is both thrilling and safe. If there is a very sharp end in the polynomial, then it will create, in designing the roller coaster, it will create a huge problem. So, unique point where tangent is there is not safe at the topmost point for a roller coaster. Okay, whatever. I am not here to discuss all these things in details today. I just bring the interest among you to study all these things in future or designing model on practical application of polynomials. Let us start with the definition of polynomial. This is an expression consisting of variables, also called indeterminates, and coefficients that involves only the operation of addition, subtraction, multiplication and non-negative integer exponent of variables. Many things are stated here without any mathematical expression. That is not possible by now. So, we will be starting writing a polynomial. That is, a polynomial is what? Expression involving variable. One variable will be there. A polynomial, we can write this form, that is in terms of the variable x. When only one variable is there, this is going to be a polynomial. A0 x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2 up to an, where n will belong to the set of whole number. N must belong to the set of whole number. Different types of polynomials will be there depending on the values of n. That I will definitely explain. If we write the polynomial in this form, and if you are ready to accept this x as variable and a0, a1, a2, an, these are coefficients. I will say these are all complex numbers because real number also complexes. So, if in the strict sense, if I say that a0, a1, a2, these are called coefficients. These coefficients may be real number, may be purely imaginary number, may be a complex number. Now, these are coefficients and this is going to be a term of the polynomial. A0 x to the power n is a term of the polynomial. A1 x to the power n minus 1 is a term. This is a term. So, polynomial is made of terms. And there is a variable also. This x is the variable here. X is indeterminates. So, x is the variable. Now, if you write it in the form y as the polynomial, then this y going to be a function of x. Those who have studied polynomial in class 9-10 level, they must have used this symbol for polynomial, px equal to a0 x to the power n plus a1 x to the power n minus 1, a2 x to the power n minus 2, this plus an. If you are familiar with the concept of function, there are two variables. You write y or px, whatever, and the variable x, they are related by this relation. So we can refer px as a function of x. We can write a polynomial function either by using this letter fx or px, that is a0 x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2 plus an. I told you n must belong to set of whole number. This n actually will indicate the degree of the polynomial. N, this integer, will indicate the degree of polynomial. N stands for degree of the polynomial. And a polynomial is said to be real polynomial, which is going to be our discussion at present, at least for this session. The real polynomial is what? In case of real polynomial, these coefficients are going to be real numbers. a0, a1, a2, an, they belong to C. But if complex part is 0, they will represent a real number. In case of real polynomial, all these coefficients are real number. So you understand a polynomial, you understand the degree of polynomial, the term of a polynomial, coefficient and the variable involved, and that polynomial can be seen as a function. If you have started today only for any examination, all these things you should keep in your mind. And now we are going to see a real polynomial example. This is a polynomial with real coefficients, so this is going to be a real polynomial. 3, 2, 1, all these are real numbers, so these are real polynomial. And in addition, you can say that 1 is the absolute term, because no x is involved over there. This polynomial has degree 2. Here degree of the polynomial, we will write dg px is equal to 2. The polynomial can have 0 degree. Polynomial can have 1 degree. Based on that, polynomials will be of various types. If we just write a few over there, polynomials, different types of polynomial, then we can say that a constant polynomial. What is a constant polynomial? A constant polynomial where n is going to be 0. Here we have said n is there. A constant polynomial is of the form fx equal to k. Here index is 0, n equal to 0 over there. This is called constant polynomial. A first degree polynomial is of this form, first degree polynomial. A first degree polynomial can have maximum 2 terms, that is fx equal to a0x plus a1. Here n is what? N is equal to 1. This is first degree polynomial. This has another name that is called linear polynomial. Polynomial may be quadratic polynomial, that second degree or quadratic. Second degree polynomial will be for n equal to 2. third degree polynomial, n equal to 3. If you write the example of second degree polynomial, it will be fx equal to ax square bx plus c. Okay, this is quadratic polynomial. You must have heard for quadratic equation. In the next topic, when I am going to do theory of equation, understanding quadratic polynomial will be an integral part of it. Okay, a cubic polynomial, that index going to be equal to 3, a cubic polynomial. Cubic polynomial will be of this form: fx equal to a0 x cube, a1 x square, 4, maximum 4 terms will be there, a1 x square, a2x plus a3. a3 may be 0, a2 may be 0, a1 also 0, but the leading coefficient can never be 0. The same manner here also, a cannot be 0. Here a0 cannot be equal to 0. A polynomial is said to be of nth degree if this is a nth degree polynomial if a0 not equal to 0. Please remember this. Other coefficients, all other coefficients may be equal to 0, only a0 is not equal to 0. Then it is said to be a polynomial of nth degree. We can add two polynomials. Addition is well-defined term here. We can make two polynomials equal. Under what condition two polynomials are said to be equal? First thing, let there be two polynomials of same degree. Then only you can compare. They must be of same degree. Let fx equal to a0 x to the power m, a1 x to the power m minus 1 plus an, writing in brief, and another polynomial you take gx equal to b0 x to the power m, b1 x to the power m minus 1 plus bn. If we say fx equal to gx, this will imply that a0 x to the power m, a1, they are of same degree. You must have seen that. What's the degree of this polynomial? That is m. m is the degree for both the polynomials. So they are equal, a1 x to the power m minus 1 plus this way am equal to b0 x to the power m, b1 x to the power m minus 1 plus bm. This will imply that if you compare these two, that a0 going to be b0, a1 going to be b1, and that am going to be equal to b. So two polynomials are said to be equal if their coefficients are comparable. And the most important condition is that they must have the same degree. Now how to add two polynomials? Their polynomials can have two different degrees. And here in this case, when you compare, they are equal degree, but here it is not. Let fx equal to a0 x to the power m, a1 x to the power m minus 1 plus am, and gx equal to b0 x to the power n, b1 x to the power n minus 1 plus bn. So fx plus gx, when you add, what is going to be the degree of the resulting polynomial? I'll explain with the help of an example here. But if we add these two polynomials, we cannot add if their coefficients are not equal. So degree of fx plus gx without addition we cannot do. Better I explain with example, then I draw the conclusion what can be degree of fx plus gx. Let us take fx equal to say 2x cube minus 3x square, 7x plus 1, and gx equal to x4 plus 8x cube plus 4x minus 3. If you add these two, fx plus gx going to be what? You can add only similar terms. It is going to be x4, 8 plus 2, 10x cube, corresponding coefficients you can add. Here no x square, so there will be minus 3x square, 7x minus 2. Okay. So degree of polynomial is maximum of these two degrees. Okay. So if we want to write degree of fx plus gx, then it will be the maximum value of m and n. You find the maximum value of m n, then you will find the degree of the resulting polynomial, that fx plus gx. Subtraction I don't want to mention separately. It will have the same thing where corresponding coefficients you can add. But for multiplication, what to do? Multiplication you need to understand what will be the degree of polynomial if two polynomials in this form, that fx equal to a0 x to the power m, a1 x to the power m minus 1 plus am multiplied with gx equal to b0 x to the power n, b1 x to the power n minus 1 plus bn, and n not equal to m not equal to n. If you multiply these two polynomials, then you have to multiply term by term. That a0 into b0 x to the power m plus n will be there, plus a1 b1 x to the power m plus n minus 2. This way it continues, and finally the two constant terms a and bn will be there. You have assumed that it is of degree m, so a0 not equal to 0, b0 also not equal to 0. So what is going to be degree of fx into gx? The degree of fx into gx going to be equal to degree of fx plus degree of gx. Okay. Why I am doing all these things in details? Because initially I told you this is the language of algebra. Algebra is the heart of mathematics. Without algebra, you cannot think even anything in mathematics. Algebra related to all the fields. So we should learn from the beginning, and this session will be for those also, those who are starting from scratch. Today is the first class. Okay? Let me go step by step. So far, addition, subtraction, multiplication, I told you. Question automatically arises, can you divide a polynomial by another polynomial? Of course you can divide. This you are seeing it from your class 7 and 8 level where algebra started, division was there. It is possible. And that only I am going to write in the form of division algorithm. Okay, what is that? That division algorithm there in number theory, it is there in case of polynomial also. If you have two polynomials, I have taken here as ax and bx, where bx is non-zero. It may be constant polynomial, but 0 is not possible. You cannot divide by 0. Then there exist unique polynomials qx and rx. That qx will be referred as quotient and rx will be referred as the remainder. QX stands for quotient and RX stands for remainder. Okay? So if you divide a polynomial AX whose degree larger than BX, then you can always express AX in the form BX into QX plus RX. And remember, degree of Rx should be always less than the degree of Bx, not equal. Then you could have divided once more. Like if we divide a polynomial by x plus 2, polynomial I am taking this form, x cube minus 3x plus 7. Then go by normal division. Synthetic division I will tell you today only. Go by normal division here. You take x square here, there will be x cube plus 2x square. Subtract, it will be minus 2x square minus 3x plus 7. Then you take minus 2x square minus 4x plus x plus 7. You got the quotient here, that is x square minus 2x, you got the remainder also here. So quotient is QX is x square minus 2x, remainder is x plus 7, and finally you have divided this polynomial, that x cube minus 3x plus 7 by what? By x plus 2. So everyone can write it now in this form, that x cube minus 3x plus 7. What is quotient here? X square minus 2x. You have divided with this x plus 2, and that remainder you got there, that is x plus 7. So this part is like ax. You have divided ax by what? By x plus 2, that is bx. This part is qx and this part is rx. You can see that degree of x plus 7 is 1. Okay? So question arises, is the division complete? No, division is not complete. That's why I have stopped here. Because here degree of this thing is equal to degree of this. We can divide once more. How to divide it? Here you take, so long it is not completed, it will show you that degree of this is larger than this or equal to this. If you take plus 1 over there, this is going to be x plus 2. 5. So actually this thing was not correct. Remainder is 5 only. And 5 is a constant polynomial whose degree is 0. You have divided with x plus 2. Its degree is 1. So degree of this remainder, now quotient initially was not correct one. It will be x square minus 2x plus 1 and remainder will be equal to 5. And on dividing this by x plus 2, it is going to be equal to x plus 2 multiplied by x square minus 2x plus 1 plus 5. So which part is going to be the quotient? You have divided this term ax by bx. So this is the quotient x. This is bx and this is ax. Okay? And this is the value of rx. This process will continue so long these don't have the index less than equal to this. That's why I told you it is less than, not less than, equal to. Okay? Now, obviously, we have to learn tricks where division shows better than the way you have done it in your classes 7, 8, 9, 10. here I am going to give you the introduction to this topic that is called synthetic division. I have asked in this problem that this polynomial is there, you divide by this. Find the quotient and the remainder. See, synthetic division is division only. But this is a version where you divide very smart. How this is being performed here? X minus 1. You take the constant term with negative sign here always. And write the coefficients of 4, 3, minus 2 and 1. I mean coefficient of leading term. Next one, next one, next one written here. Then what you will do? Just below you draw a line here. In this line, you will be writing the leading coefficient. Because it is polynomial of first degree and this 4 is the coefficient of leading term. So 4 has to be there. Or you understand the method now. Now multiply this 4 by 1, result is 4 here. Then adding these two, result is 7. Multiply 1 by 7, it is 7. 7 minus 2 is 5. Then 1 into 5 is 5. Put it there and then simply add. So 1 plus 5 equal to 6. What have you got there? You have got the quotient. You have got the remainder. The last term going to be the remainder. So if you divide this polynomial by this, that 4x cubed 3x squared minus 2x plus 1, then this is going to be x minus 1. This whole thing is x. This part is bx with what we are dividing. Then this part will be qx always. And this is the rx. Okay. So you write. And this polynomial, when once you divide by x minus 1, will be the index and degree less than by 1 from this. So there will be 4x cubed plus 7x squared plus 5x plus 6. This is quotient I have written here and this is the remainder. This method, believe me, is very useful. Not only in polynomial but in case of theory of equation only, which is going to be our next topic. So, synthetic division is this simple one for dividing a polynomial by another polynomial. I have taken a first degree polynomial, this is cubic polynomial. You might have questioned, what will happen if you do it with division, if you do it with a higher degree polynomial, quadratic one, then what is going to happen? Wait, I will explain everything one by one. You first master this topic that is called synthetic division. Let me show you another example on synthetic division. We are going to divide this polynomial by gx equal to x minus 2. Using synthetic division, find the quotient and remainder. Same method. The absolute term here is minus 2, make it plus and take it here. Change the sign of the absolute term, take it here and write the coefficients one by one. That is 2, minus 3, 5 minus 1 and 6. Once more. So what will be our first step? You bring it down. These two, draw a line here, bring it down here. These two will go straight there. Now multiply these two by these two. Here it will be 4. Now add. So 4 minus 3 is 1. 1, then 2 into 1 is 2. Then add these two. Which two? 5 and 2. You are going to add over there. Then it is 7. Now multiply the result. 7 by 2 it is 14. Then add these two. 13. And 2 into 13, 26. That is 32. I told you the last one going to be the remainder here. And this is going to be the quotient. So when you write fx, I mean 2x4 minus 3x cube 5x square, this is going to be equal to 2x cube plus x square plus 7x plus 13, and this you have divided by x minus 2, and remainder is 32 over there. So this was our ax, this one was our ax. You have divided by this, this is going to be the bx, b. This is going to be the qx, the quotient, and this is the remainder here. Hope you have understood. Not a difficult topic at all. But synthetic division 9, 10 level. Either I just remind you, or if you have not done it yet, this will help you a lot. So, when a polynomial fx being divided by x minus a, the remainder going to be fa, and the polynomial, the value of polynomial at x equal to a will give you the remainder. Suppose for this example, fx equal to x cube plus 2x square minus 3x plus 1. You are dividing by x minus 2. What is a over there? A is equal to 2. So what is going to be the remainder? You put x equal to 2 on both sides. Just put x equal to 2 on both sides. That is going to be the remainder. So f2 is 2 cube plus 2 into 2 square, 3 into 2 plus 1, 8, 8 minus 6 plus 1, that is 11. So synthetic division is not required here. So powerful theorem, only just finding fa. Fa will give you this. But you cannot say that we don't need synthetic division. I will show you many examples where synthetic division also work very nicely. Okay, whatever, remainder theorem I hope you have understood. Now, if you are writing this thing that fx equal to that x cube plus 2x square minus 3x plus 1, this can be written as, what is the quotient here? Have you got it? No. You got this remainder part. Remainder part you got. Quotient you haven't got. To get the quotient, synthetic division is required. That's why I was telling you. Just one example you see, later on I will show many examples of synthetic division. I will prove that this is also integral part of learning polynomials. Now what is factor theorem? Very simple. If this f2 is not, fa is not there, I mean remainder not there, then x minus 2 going to be the factor. Agree or not? Now what is factor theorem? If that fa is not equal to 0, for a polynomial fx, then x minus a going to be factor of fx. Conversely, x minus a is a factor of fx, then fa equal to 0. So if remainder is 0, remainder is fa, then obviously x minus a is going to be a factor. For example, if we have the polynomial fx equal to, say, x square minus 5x plus 6. What is the value of f2 here? Just put 2 square is 4 minus 5 into 10 plus 6, 0. So we will say that x minus 2 is a factor of this thing. What about f3? Let us check. This is 3 square, 5 into 3 plus 6, that is 15 minus 15, 0. So x minus 3 is also a factor. Clear? Hope you have understood. Now, another thing is there. If you say that the polynomial vanishing for x equal to a, then we will be referring a as the 0 of the polynomial. Okay? Because it is making the polynomial 0, say, so a going to be the 0 of the polynomial. So in this problem, in our problem, x equal to 2 and x equal to 3 are two zeros of the given polynomial. Okay? So this is just introduction to polynomial, which I was supposed to start in this session, supposed to state in this session, that I have done.